So this is the given problem. So step 1, subtract minimum element from each row, which results in the matrix as given below. So now I'll identify the minimum element of each row and subtract that minimum element from all the elements of each row. So for the first row, if you just see what is the minimum element, it is 13. So subtract this minimum element from each of the element of the first row, which will give 15 minus 13 is equals to 2, 13 minus 13 is equals to 0, 14 minus 13 is equals to 1, 17 minus 13 is equals to 4. And similarly in the second row, the minimum element is 11. So 11 minus 11 is 0, 12 minus 11 is 1, 15 minus 11 is 4, 13 minus 11 is 2. In the third row, the minimum element is 10. 13 minus 10 is 3, 12 minus 10 is 2, 10 minus 10 is 0, 11 minus 10 is 1. And in the fourth row, the minimum element is 14. 15 minus 14 is 1, 17 minus 14 is 3, 14 minus 14 is 0, 16 minus 14 is 2. Repeat the same procedure column wise. That means identify minimum element in each column and write down the matrix again. So if you see in the first column, the minimum element is 0, so there will not be any change in the column element. Similarly in the second column, there is a minimum element as 0. Even in the third, the minimum element is 0, so there will not be any change in the columns 1, 2, 3. But if you see in the column number 4, the minimum element is 1, and subtract that minimum element from each element of this column number 4, which will result in the matrix so no change in the first 3 columns because there is a minimum element as 0 in each of the columns. But in the fourth column, the minimum element is 1. Subtract that minimum element from each of the column elements. So 4 minus 1 is 3, 2 minus 1 is 1, 1 minus 1 is 0, 2 minus 1 is 1. Now I'll do the assignment. So how to do the assignment? So first you start row wise and then column wise. So in the first row, identify the 0 such that it should be the single 0 in that particular row. So if you see in the first row there is only 1 0, I will assign this and check that particular column in additional number of zeros. If there are additional number of zeros, you need to cancel that particular 0. In the second row there is only 1 0, I'll assign this, I'll check this column for additional zeros, there are no zeros. Then there are in the third row there are 2 zeros, so right now I will not assign this because there is an ambiguity which 0 I need to select. In the fourth row there is only 1 0, I will assign this, and at the same time I'll check this column for additional number of zeros and I'll cancel this. Now again repeat the procedure column wise. So here in the first column already assignment is there, in the second column already assignment is there, in the third column already assignment is done, in the fourth column only 1 0 is there, I'll assign this. Now if you see, these are sub assemblies These are contractors. So 1 2 3 4, 1 2 3 4. Now if you check the assignment of sub assemblies to contractors, what I'll get, so first sub assembly is given to contractor number 2, second is given to 1, third is given to 4, and fourth is given to 3. And the assignment cost from the original matrix, I need to just take it down. So 1 to 2 is how much? 13. Then 2 to 1 is 11. 3 to 4 is 11 again, and 4 to 3 is 14. So if I add this, I'll get total assignment cost as 3 plus 1 4 plus 5 plus 4 9, 49 rupees. So this is the total minimum assignment cost. So this was the very simplest problem that we can solve in assignment models, but remember, such type of simple problem will not be asked in the exams. So I'll take bit complicated problem than this. Okay, so we'll see the next problem in the next video. Thank you.